1 plus e power of 1 by 1 plus e power of EF minus ED by KT. Okay. And the ND multiplied by here. What will be the next step? The next step is to just do the LCM. Okay. Just do the LCM and then cancellations if possible. Yeah. And then write down here ND multiplied by e power of EF minus ED by KT divided by 1 plus e power of 1 plus e power of EF minus ED by KT. Okay, 1 plus ED by KT. Now I'll write down here. What you will be getting it here is ND multiplied by e power of EF minus ED. F minus ED by KT. Okay, and divided by 1 plus e power of EF minus ED by KT. Okay, so this is what you will be getting it here. Okay, so I'll tell you what. See, ND multiplied by e power of EF minus ED by KT whole divided by 1 plus e power of EF minus ED by KT. Okay, so now we have to put a condition here. What condition is e power of EF minus ED by KT is very much greater than 1. That's one of the conditions. Then EF minus ED is very much greater than or equals to KT. Okay, then as a result, ND by e power of E minus EF by EF minus ED by KT. Then what will happen is, then you'll have ND multiplied by e power of ED minus EF by KT. Okay. So what will happen? This second equation we have written to, and the first equation also we have written. So these two equations we have just equated as the density of electrons equals to density of holes. We have to just equate it, okay, and then taking the logarithm on both sides and try to simplify it. Okay, so in the finally we will be getting a conclusion that the EF will become here EF is equals to ED plus EC by 2. Okay, so this is it. So here today what we have done is we have taken up the derivations of this revise that we have found out the carrier concentrations of electrons we have done, okay, and the carrier concentrations of holes we have done, and in case of intensive semiconductor the derivations has been done, both the derivations, and I told you about the Fermi level, okay, Fermi level also we have derived, and then just now we talked about the n-type semiconductor, okay, that in case of extrinsic semiconductors, okay, one of them has been discussed, and the rest we will be discussing in the next class. Okay, we have here the derivation for the p-type semiconductor, and followed by next one is we have lasers, very interesting lasers. Okay, introduction to lasers, properties of lasers, characteristics of lasers. We have the methods of preparations of lasers by various methods. Okay, quite interesting topics to go. Okay, with this I'll conclude it, and thank you very much for joining.